All right, so we're continuing learning about place value. This is session 2 for lesson 6. And for the warm up today, I'm going to help show you the relationship between the different place values just visually. And before that, just want to say if you need to, you can get a printed copy of this place value chart to kind of help be your cheat sheet for some of these homework assignments. All right, so once it's to write the number each model represents as a decimal, one flat is going to represent the value of one. So what they mean by that is normally you've been taught that these things called flats have 100 squares on them, 100 cubes, and those are a value of 100. But they can be used to kind of teach decimal place value. So decimals are basically taking a whole number and then breaking up into small little pieces. So each of these is going to be worth 1.0. So instead of equaling 100, this is visually going to represent one whole. And each one whole has 100 different parts to it, but we'll get to that in just a moment. So if we add all these up together, that gives us a value of 5.0. So next, they're asking what value do you have represented here if you have these 5 things. These are called rods. And normally you would use these to represent 10, but now these are used to represent a tenth because if we laid one of these over a flat, one of those squares, you would see that it covers 1/10 or one of the 10 parts. So these are 1/10. And my 1 is in the tenths place. And then if I add all these up together, I have 5 of them. Each is worth 1/10. That gives me 5/10. And if that also 0.5 represents half, so these could cover up half of one of my squares or flats. And lastly, a single unit cube if is going to be 1 out of 100 if we focused on that. So these are worth a hundredth, and that 1 is in the hundredths place. Got to say it properly. And if we have all 5 of these and we add them together, that gives us 5 hundredths. So again, this is going to help us with our classwork notes and also help us start really understanding what place value and decimals, where they come from. All right, speaking of the notes, let's get started with those on page 125. And how we do this is this. For part 1, it's important we shade this properly because it's going to help us answer things from question 2. But it wants us to shade the value that we have here for all these. So we know from the warm-up that all of these grids are worth 1 total. So they want us to show 3.0. So I'm just going to quickly shade these in. And that shows 3. Under B, it shows 3/10. And we remember that tenths is one of these long ones. So we're gonna fill in 3 of those. So 3/10 of this whole has been covered up. And this is 3/100, and that just means I've got to fill in 3 of those cubes. Now, before I move on to 2, I'm gonna kind of answer that question by showing you the relationship between these. Now, we learned yesterday that if you multiply by 10, it moves your digits into a bigger place value. So for 3/100, if we multiply that by 10, notice the 3 gets put into the tens place. If we take 3/10 and we multiply that by 10, that takes that 3 in the tens place and bumps it over to the 1. We also learned yesterday the opposite is true. If you divide by 10, like 3 divided by 10, that 3 will move over one place value into the smaller place value here in tenths, and then 3/10 divided by 10 gives us 3/100. So just keep that in mind as far as the relationship between both. And visually, you can see that happening here. How when you divide, you just get smaller and smaller. And then when you multiply, you get bigger and bigger. So let's look at the questions in 2. So it says, basically, we just did this anyway up above, but we're just going to put it down here. So we multiplied 3/100 times 10. That gave us 3/10. We multiplied 3/10 by 10, and that gave us 3 whole. We took 3 whole and divided it by 10, and that gave us 3/10, and then we divided 3/10 by 10, and that gave us 3/100. So it's all about that 10 is powerful. It shifts your numbers a whole place value each time. So it's kind of interesting that it happens that way. And for this next part, so for these, we want to talk about these in terms, so this is another way of thinking about it. So 3/100, that's our smallest value there. And that means that's 1/10 of the next bigger one, which is 3/10. And to show that mathematically, if we multiply 3/10 times 1/10, that will give us 3/100. And then we also know that 3/10 is 1/10 of 3. So if we do 1/10 times 3, 3.0, that will equal 3/10 right up there. So kind of interesting how that works. All right, go ahead and turn the page. Now these number lines are going to be used to, these number lines are going to be interesting way of representing it like this. So it says fill in the missing labels for the red tick marks. So these little red lines here are called tick marks, if you ever wondered what those meant. So let's fill in what's missing. Again, if I'm going too fast, you can always pause. I kind of just do the videos fast because you do have that ability to pause or rewind or do whatever you need to do. This third line is interesting because it uses, the second line uses a tenths place. This third line uses the hundreds place. So all of ours have to be having a hundreds place value here. All right, and then this last one, 1.00. Okay, so we'll keep referring back to that. It may not be on the screen, but you can just glance at your workbook and get your answers for that. All right, so number 5, how does the distance from 0 to 1 compare to the distance from 0 to 1/10 and the 0 to 1/100? 0 to 1 is a value of 1, 1.0. 0 to 1/10, that is just 1/10. And I just want you guys to write that in there to get used to that and get the connection. Zeros, let me erase this. 0 to hundreds, that is this 100. Right? On to question 6. How do decimal grids and number lines help you understand the relationship between adjacent? That means under here, right next to place values in our number system. So adjacent, and I'm going to even write that here, next to place values are 10 times bigger or 1/10 smaller. So that's the rule. Your 1/10 and 10 times are, excuse me, I should have put a period there, are related to each other that way. Last question. I know there's a lot of notes for today. This last one. How many times greater is the value of 1.5 than the value of 15/100? It's 10 times greater. And it's 10 times greater because the digits, you'll notice the 1 and the 5, they're exactly one place value different from each other, if you can look at it like that. Okay, so let's look at the homework. It's going to be IXL G10 decimal number lines, very similar to what we just did here. So work on that until you get 70% or a bronze medal. You can work to 100 to get a house ticket. All right, good luck.